Hello everyone, welcome to Cracku DILR series. In this series, we are covering 100 plus CAT level DILR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DILR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DILR practice, then this series is for you. And if you want more DILR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DILR sets.
So basically what is mentioned is that this is a manufacturing unit. The revenue is fixed. The revenue we are told is for 50 units, it is 1000 rupees. So the revenue per unit is rupees 20. The variable cost also is per unit. It is also fixed per unit. So the variable cost per unit is for 50 units it is 700. So it will be rupees 14 per unit. The fixed cost is not dependent on the number that is produced. The fixed cost is rupees 50 if the number produced is less than or equal to 34, and it is rupees 100 if the number produced is greater than 34. Now what we are required to calculate is the number of units that are needed to be produced so that there is no loss. Let us first consider the case that this value n is less than or equal to 34. Then what is the total profit? The total profit is the revenue, which is 20n, minus the fixed cost, which is 50, because here we assume that n is less than 34, minus the variable cost, which is 14n. This is the profit. We want this to be greater than or equal to 0. Or we want 6n to be greater than or equal to 50, or we want n to be greater than or equal to 8.67. So essentially what we are telling is that if the number of units produced is equal to 9, this profit is greater than 0. Therefore, there will not be a loss. So the minimum number of units that should be produced is option B. Let us look at the second question. What is the least number of units that should be manufactured so that the profit was at least 50 rupees? So let us again assume that the number n is less than 34. So what is the profit? The profit will be equal to revenue, which is 20n, minus the variable cost, which is 14n, minus the fixed cost, which is 50. This has to be at least equal to 50, or the value of 6n has to be greater than or equal to 100, or the value of n has to be greater than or equal to 16.67. This would imply that the smallest value that n can take is 17. Let us look at the next question. If at most 40 units can be manufactured, so for 34 units less than or equal to 34 units, the fixed cost is 50. When n is greater than 34, but as mentioned over here, only 40 units can be produced. If it is lying between 34 and 40, the fixed cost is 100. Then what is the number of units that can be manufactured to maximize the profit per unit? Okay, now we are not looking at profit, we are looking at the profit per unit. In this case, what is the profit? The profit again is revenue, which is 20n, minus the variable cost, which is 14n, minus the fixed cost, which is 50. This is 6n minus 50. This is the total profit. So what is the profit per unit? It will be divided by n. This is equal to 6 minus 50 by n. We are trying to maximize this. We'll maximize this as the value of n increases. Because this is 6 minus something, we want 50 by n to be as low as possible. So if the value of n increases, this one increases and it hits a maximum when n is actually equal to 34. And it will be equal to 6 minus 50 by 34. 50 by 34 is approximately 1.5 because 51 by 34 is 1.5. So this is approximately 4.5. Now suppose n is greater than 34 but less than or equal to 40. What is the profit? Again the profit is revenue, which is 20n, minus variable cost, which is 14n, minus the fixed cost, which is 100, which is equal to 6n minus 100. But this is the total profit. We are looking at the profit per unit. So divide this by n. This is equal to 6 minus 100 by n. We are trying to maximize this. Again, this is maximized when the value of n increases. And the value of n increases and it can touch a maximum of 40. So what is its value when n is equal to 40? It is 6 minus 100 by 40. 100 by 40 is 2.5. So this is 6 minus 2.5. which is equal to 3.5. So the maximum value it takes is 4.5, approximately 4.5, and that happens when n is 34. So the answer for this question is option B. Let us look at the next question. If the production cannot exceed 45 units, what is the number of units that can maximize profit per unit? Again, similar to the earlier question, again when n is less than or equal to 34 and greater than 34 but less than or equal to 45. When it is less than or equal to 34, what is the profit? It is 20n minus 14n minus 50. This is 6n minus 50. This is the profit. Again, we are only looking for profit per unit. So divide this by n, and the profit per unit is 6 minus 50 by n. This will increase as the value of n increases, and n can be a maximum of 34. So this is again equal to 6 minus 1.5, which is very close to 4.5. When the value of n is greater than 34 but less than or equal to 45, the fixed cost becomes 100. So the profit is 20n minus 14n minus 100, which is equal to 6n minus 100. This is the total profit. We are looking at the profit per unit. So divide this by n. This is 6 minus 100 by n. Again, we want this to be maximized. This is maximized when n is equal to 45. So this is 6 minus 100 by 45. 100 by 45 is basically 20 by 9. 20 by 9 is approximately 2.2222. So this is 6 minus 2.2222, which is equal to 3.77. Again, the highest is 4.5. This happens when n is equal to 34. So the answer for this question also is option B, which is 34. Let us look at the last question of this set. If the fixed cost per production goes up by 40 units, so when n is less than or equal to 34, the fixed cost is 90. When n is greater than 34, the fixed cost is 140. What is the minimum number of units that need to be manufactured so that there is no loss? Let us consider this case first, where n is less than or equal to 34. What is the profit? It is revenue, which is 20n, minus variable cost, which is 14n, minus the profit, which is 90. This has to be greater than or equal to 0, because we don't want any loss. So we want 6n to be greater than or equal to 90, or we want n to be greater than or equal to 15. So the minimum number of units that should be produced so that there is no loss is 15. At this point, there will be no profit and no loss.
Stop wondering which ions will call you. Get the most accurate answer. Cracku's ion call predictor analyzes everything: your academics, your work experience weightage, and even the job process, all based on the latest RTI data. Know the exact cutoffs and your precise chance in seconds. Ready for clarity? Just Google search Cracku ion call predictor. Your personalized IM report just is search away.